see. It's preparing the live stream now, so. So many buttons to push to do this. In the live stream now. Oh. So many. Okay. All right, we're live. And Richard, I'm going to mute me since I don't want the echo coming back through. And then you can just take it from in 5 minutes, you can just kick it off.
Okay.
I paused the live stream until we get started.
So I guess a question on logistics. I know we talked about picking up, starting with the demo that we didn't get to last time. Is there a certain amount of time that we want to leave for Q&A? Does it matter to you guys?
No, this is your show. So, obviously I'll kick off the recording here and we'll be live streaming it at the same time. So we'll get it recorded twice and in two different places. So it's whatever you're comfortable with. I know some people missed the live one last time. So summarizing that and then going into the demo and then how much ever time you have left after that to take folks' questions would be great.
Yeah, I think I'll do just a couple of minutes of kind of review from last time as introduction for the demo. And then the demo will be 25 or 30-ish minutes. And then however much time is left over, we can do Q&A if that's cool with you all.
Yeah, that sounds real good, Doug.
And for those who are an attendee and asking questions, because this is a webinar and we are recording, if you could put your questions into Q&A or into the chat, that would be great. And Richard will go over all of that here in about 2 minutes. So when we get started, so he'll explain how to ask questions and stuff like that. So when you hear this call is being recorded, you'll know to take it from there, Richard.
Okay.
Should I go ahead and share my screen now?
Yeah, that'd be good.
All right, so you should see my slide deck.
Yep.
Yes. Hello, everyone. Welcome to another session with the Zeek community. Here we have Doug Burks back again. We got through a good amount of material surrounding Security Onion in the last session, but we never got around to the demo. And I think a lot of people were really interested in seeing that. So Doug graciously agreed to return, and he's here with us today to he'll give a little bit of an intro to Security Onion for people who might have missed the previous session. But then after that, he's going to do a demo and answer questions. If you do have questions, you'll see that there is a Q&A button at the bottom of the Zoom interface. We recommend that you put your questions there. If you put them into chats for more things like problems you might be having with the session. So instead, put them in Q&A. It makes it a little bit easier to track. If at some point Doug sees a question, he wants to answer it, he's, go ahead and feel free to do that, Doug. Otherwise, I may try to moderate those a little bit so that you can continue with delivering your content and not worry so much about the interface. Yeah, so with that, happy to turn it over to Doug.
Well, thank you, Richard. Again, I appreciate the introduction and the invitation to be here. Certainly had a really great time last time, and appreciate the invitation to come back and join you again. And just administratively, I don't actually see the chat window at this point now that I've shared my screen. So if you could moderate the questions and feed them to me, that'd be great. And we can have some good discussion like we did last time.
Okay, cool.
So as Richard said, just a quick kind of review of last time for those who may not have been able to join on the last call. Some brief background information about Security Onion. Security Onion is a free and open source platform that I started way back in 2008 to give you the best of breed open source components to help you peel back the layers of your enterprise and make your adversaries cry. So we include Zeek, Suricata, the Elastic Stack, all of the best of breed open source components for things like intrusion detection, network security monitoring, threat hunting, and all of the things that you need to monitor your networks, monitor your endpoints, bring all of that data back to a central location and slice it and dice it so that you can hunt down those adversaries that may already be inside your environment. So Security Onion, the current platform that we have is called Security Onion 1604 because it's based on Ubuntu 1604. And one of the things we talked about in the previous session was the amount of importance that I place on keeping those components up to date. And we talked a good bit about keeping those Bro and Zeek packages up to date throughout the years and keeping track of those releases. And just as a further evidence of that, on Tuesday, our good friends at Zeek released Zeek 3.0.7. And as soon as that dropped, we started our packaging process. We started our Q&A process, our QA process. And we released those packages this morning. So it's very important for us, especially when it comes to security fixes, that we spring into action immediately so that folks are able to worry less about keeping up with the latest and greatest updates, and they're simply able to run our simple update command that we call soup. And that makes sure that all of their sensors and all of their backend systems are kept up to date. So if you are running Security Onion in production today, make sure you run soup to get that latest version of Zeek 3.0.7. So that's just a little bit of a brief overview of the current platform. Another thing that we talked about in the previous session is kind of our next generation platform that we've codenamed Hybrid Hunter, because we're building a new platform that's trying to give you the most efficient experience when it comes to hunting, but hybrid because we want to support not just Ubuntu, but hopefully other Linux distributions as well. And so Hybrid Hunter is container-based. So whereas the previous platform was built using Ubuntu packages that limited us to Ubuntu 16.04, Hybrid Hunter is now container-based. And if you go and download Hybrid Hunter today, you can run that on CentOS 7 or Ubuntu 18.04. And so that conversation kind of led us up to talking about Hybrid Hunter and specifically a lot of the new features that we've introduced in this new Hybrid Hunter platform, specifically around community ID. And we talked about the fact that, you know, it's amazing of the Zeek community to come up with this community ID, this value that helps tie different data types together. It helps you correlate from Zeek logs to Suricata alerts to other data types as well, and do it very quickly and easily. And we think that's a genius move. And so we're embracing that wholeheartedly. And so we've done a lot of work in Hybrid Hunter to really make that community ID a first-class citizen, really make it first and foremost one of the things that you use quite a bit, and we leverage it quite heavily. And so what you see on my screen is one of the slides that we quickly covered last time. And so the point of this slide is that in Hybrid Hunter, we are enabling that native community ID support in Zeek. So that's essentially just flipping a flag and turning that value on and getting those community IDs generated by Zeek out of the box. So we see that in this screenshot here. This is our new web interface for threat hunting. And so what you can see in the query there is we're taking all of our Zeek logs and then we're grouping by the community ID. So you see those unique community ID values and account for each of those. Now, on its own, just looking at Zeek community ID values is not really that interesting. What's much more interesting is when you start to tie those individual community ID values to wherever else they may exist, which might be Suricata alerts, it might be other data types. So in my next screenshot here we have Suricata. So in Hybrid Hunter, we're also enabling the native community ID support in Suricata. Again, we're just flipping the flag in the suricata.yaml file. And so now we've got community ID values being generated by Suricata natively. So that makes it really easy for us to correlate between, let's say we start with a Suricata alert and we want to kind of get the context for that. And so we can then pivot from there to the contextual Zeek logs. So we can kind of fill in the gaps with our Zeek protocol metadata and really paint a more complete picture of what happened. Because a lot of times that we find, you know, working our incidents, that the IDS alert itself really just might be the tip of the iceberg. It might give us a hint of what's going on. It might kind of raise a question, but in order to fully answer the question as analysts, we need to fill in the gaps and we need that extra contextual data. So then where can we go from there? What else can we do with community ID? Well, let's say that in that hypothetical example that we started with a Suricata alert and using the community ID, we pivoted to some Zeek logs, which gave us some additional context. But then we want to take it a step further. We'd like to see what was the actual process on some particular host that originated that particular traffic flow. Well, with OS Query, we can actually do that. We sponsored the addition of some community ID support in OS Query. So if you deploy OS Query agents, you could then run a query like this and you could say, hey, go and find this community ID value. And it could tell you that that traffic flow came from, in this case, Netcat trying to connect out to osquery.io on port 443. So now we're kind of tying all of that stuff together, right? We're tying back to the host, we're tying back to the process on that host. And so that's great if you're running OS query, but what about other things, right? What about other tools where maybe it's not open source, maybe we can't easily add in features like community ID support? And so a great example is Sysmon. And so I've got a screenshot here of a GitHub issue. So if you go out to the GitHub repo for the sysinternals set of tools, somebody has requested community ID support be added to Sysmon, and they've essentially accepted that as a feature request and added it to the backlog, but it hasn't actually been developed yet. It hasn't been implemented yet. And so, that's one of the things that a lot of folks that are in Windows heavy shops, which is quite a good number of organizations, they would love to have Sysmon on their endpoints to give that great comprehensive logging of processes and network connections and DNS lookups from the host perspective. But if Sysmon can't natively generate the community ID, then where do we go from there? And so for us, because we are using the Elastic Stack, and because we are parsing all of the logs that come into Hybrid Hunter using Elasticsearch ingest node parsing, we sponsored the development of a processor that could generate those community ID values for any kind of log, for any kind of data type. So as long as the log has the proper IP address and port information, Elasticsearch, as it's parsing the log, can automatically generate the community ID. And that works for things like Sysmon logs. You might think about other examples like firewall logs or something else where you can't just go and easily flip a switch and turn on some sort of native community ID support. So we're really excited about that capability of being able to consume all these different data types and tie them all together and correlate using community ID. So now to illustrate that point, I'd like to kind of walk through a demo. And in this demo, I kind of have three different use cases. So the first use case is kind of what I just talked about. And that's, a very familiar use case for a lot of folks. Maybe you get an IDS alert, maybe that's your starting point, and you want to start from there. You want to pivot on that community ID value and get some additional contextual data. And maybe that's from your Zeek logs, maybe that's from Sysmon or some other data source to give you that host-based perspective. And then the second use case is going to be kind of the other direction, kind of starting from doing some hunting and then finding some weird anomalies in my Zeek logs. From there, kind of tying that back to a different IDS alert, which gives us some additional data, and then ultimately tying that back to the host-based data. And then finally, the third use case is kind of starting from the host and then working back out to the network. So we'll kind of walk through those kind of one step at a time. All right, so flipping over to my browser window, let me kind of explain this scenario as I've set it up. I've got Hybrid Hunter, Security Onion Hybrid Hunter installed in a virtual machine. So it's running Suricata, which is monitoring my network traffic. It's generating IDS alerts. It's running Zeek, which is also monitoring that same network traffic, and it's generating those lovely Zeek logs that we all know and love. And I also have a separate VM, which is a Windows installation. So it's Windows 10, it's got Sysmon installed. Sysmon is then logging all of those connections and processes and DNS lookups. And we're collecting those Sysmon logs using WinLogBeat. And then WinLogBeat is shipping those logs over to Hybrid Hunter. And those are being then ingested into Elasticsearch. So now when I go into my new hunting interface and I run a query, I am searching across Elasticsearch and I'm getting all of those logs, whether they originated from Suricata or Zeek or Sysmon or whatever the case may be. I'm getting all of those results in one go. So starting here with a very simple query, and this is one of our default queries that we have here in the drop-down box. And this is really just a query that's going to show me all of my network-based IDS alerts coming from Suricata. So if I run that query, I get a number of alerts that have been generated by Suricata as it's monitoring my network traffic. And so we could look through this list, and really there's a good number of interesting alerts here. But just to focus in on one, let's say we find this particular alert. This is from the emerging threats rule set. It's in the policy category, and it has to do with an executable, a Windows executable served from Amazon S3. And so if I wanted to focus in on that particular alert, I could click the plus sign here. That's going to update my query at the top. I can then click the hunt button, and that's going to refresh the entire page to only show the alerts for that particular rule. And so you can see at the bottom in this events table, we have one result. And so if I want to drill into that, I can click the down arrow, and that's going to open up and show me all of the fields within that particular log. And so because this is a Suricata alert, this came from eve.json, and we've got the full message that came out of Suricata to include some of the packet payloads. So you can see here the payload printable field. And if you start kind of reading this and parsing it with your eyes, what you'll see is that this is the web server's response. We see the HTTP 200 OK. And ultimately in here, we'll see this program cannot be run in DOS mode. We see our MZ file header. So we do actually see that, yes, this is a Windows executable, but just looking at the payload, this really just starts at the web server's response, right? So one of our questions might be, well, what was actually requested? What came before that web server response? And so, yes, we get a lot of information in the IDS alert, but sometimes we're interested in more information than just that. So in order to get that extra information, we might want to pivot on that community ID value. And that's one of the default fields that we kind of expose in this events data table at the bottom of the page. So if I want to take this community ID, I could copy it and paste it into my query bar and search for that. And now I get 6 events found. And so I can tell just by looking at these results, the first 2 have a UID field, and that tells me that the first 2 are Zeek logs, right? So I'm assuming that because this is port 80, one of these is probably going to be the Zeek HTTP log, and the other is probably going to be from the Zeek con log. So if I drill into the first one, sure enough, this is from the Zeek con log. So we get some good information about the connection there. And then if I drill into the second one, that should be my Zeek HTTP log. And then that's what's going to actually tell me what was in the GET request. So in this case, we were actually requesting /exe/calc.exe. And so we get that additional context from that Zeek HTTP log, and we're able to tie those things together very quickly and easily using that community ID value. So it doesn't stop there. Those were just the first 2 entries that we had. So let's see what else we have. Now, looking at the bottom 2, I would guess that these are probably IDS alerts. So let's look at the next to last one. And this is actually a different alert than we saw previously. This is kind of a more generic alert just for any old Windows EXE, not specifically from Amazon S3, but really from anywhere. So this doesn't really give us that much more information than we had previously. But again, you see the value of if there were some other IDS alert, which might provide us some additional context about, hey, we've seen this particular activity in this kind of ransomware or this kind of Trojan or whatever the case may be, that's going to be additional context that community ID gives us. And then that last one should be the IDS alert that really started this investigation in the first place. And that's the executable served from Amazon S3. So now we go back to kind of these middle two. And so we haven't looked at those yet. So let's drill into those and see what we get. So the first one is, well, here's another IDS alert. This came from suricata eve.json. And this alert is for curl user agent outbound. So again, if we hadn't picked it up by looking at our Zeek HTTP log, then we could determine just based on looking at this IDS alert that the user agent that requested this EXE was actually a curl user agent. So that's another piece of context that might be helpful in our investigation. And then finally, if we drill into this one, this is where things really get interesting because this is the log that comes from WinLogBeat. And so this was actually originated by Sysmon. You can see that here in the event provider field. So if we look at the message field, we'll see here's the full message coming out of Sysmon, network connection detected. And one of the really cool things about this is when we parse this message field out and we get the process executable field, we actually see the process that originated that traffic flow. So in this case, this is curl. And we saw evidence of that previously, seeing that curl user agent, but now we actually see that the actual executable was curl itself and not some other process that was simply spoofing a curl user agent. And if we look at the full path, we get a little bit more information, and we can tell by this path, this is actually the Windows subsystem for Linux. So in order to kind of generate this simulated malware, I simply took my Windows host in my VM and installed Windows subsystem for Linux and ran through testmynids.org. There's a few tests there that run on a standard Linux box. And because I had Windows subsystem for Linux, I could run through that shell script and it would generate this traffic, which then generated these alerts and logs. So there you kind of see from start to finish, being able to tie from an IDS alert to Zeek logs to Sysmon logs, and really giving you that full, complete context and really paint a more complete picture because we have multiple perspectives on what's going on. So that's really use case number one. That's starting with an IDS alert and working from there. So now let's kind of move on to use case number two, and that's maybe we don't have an IDS alert that starts our investigation. Maybe we start off with just some good old-fashioned threat hunting. We're looking for anomalies. And so maybe we say, well, let's go to our drop-down box here and let's pick one of our kind of hunting queries, and let's look through our Zeek HTTP logs, and specifically let's group by user agent. Now, it's always fun to look at an enterprise, look at all of their HTTP traffic, and look at unique user agents, because it's very easy to pick out kind of your usual and customary user agents, things like Chrome and Firefox, and then start to look at the long tail of those user agents and look for those anomalies, look for those user agents that are unexpected. So I don't normally expect to see a user agent called Black Sun. I don't normally expect to see a user agent called MSIE. That's not the legitimate Microsoft Internet Explorer web browser user agent. So likewise, I don't normally expect to see a user agent called Jedi VCL. And so let's use that as our example, and let's kind of work through a very similar workflow that we did previously. So we're going to focus in on this particular user agent. So when I click the plus sign, that updates my query. I can click Hunt, and that's going to refresh the page and only show me this one log for that Zeek HTTP log with that particular Jedi user agent. So we get a little bit of a sense of what's going on here from the HTTP log. This is a GET request, and it is going out to testmynids.org. I mentioned that earlier. That's what I was using to generate all of this different traffic. So we get a little bit of a sense of what's going on from the Zeek HTTP log. But if I want to get more context, of course, even before we had community ID, we could use the Zeek UID field to kind of correlate within Zeek logs themselves. And that would give me like the con log or any other logs that might correlate within the Zeek world. But again, let's use our community ID because we might find not only Zeek logs, but also some other logs as well. So doing that search for that community ID value, I get 4 results. So let's take a look at our first one. This is going to be our Zeek con log. So again, kind of abstract information about the connection itself. The second one is most likely going to be the HTTP log that started off this particular use case. So that was that GET request. So then the last 2 are going to be different data types. These are going to be non-Zeek data types. So let's take a look at number 3 and see what we've got there. So this is going to be WinLogB. We'll save that one for last. So let's go to number 4. And this is going to be a Suricata IDS alert. It says a network Trojan was detected. And so the rule itself is in the Trojan category. And so what this is telling me is that that particular user agent, Jedi VCL, actually relates to this Delphi Trojan downloader. And so that was a piece of context. This is a piece of intelligence that I didn't have before that I've been able to instantly tie into just based on pivoting on the community ID. So that's pretty cool. And so now let's kind of revisit and go back to our host log. Again, this comes from WinLogB, which pulled this sysmon log. Sysmon saw a network connection coming from the host. And again, looking at that process executable field, we can see that, again, this traffic was generated by curl running under Windows Subsystem for Linux on that Windows box. So again, being able to tie all these different data types together and ultimately map back to the original process running on the original host and correlate that with the network traffic. So that's use case number 2. Not starting with an IDS alert, but starting with a little bit of hunting, finding an interesting Zeek log, and then pivoting outward from there. Now let's move on to use case number 3, which is the final use case, and that's really kind of starting with our host data, and that's the sysmon log. So in order to do that, I'm going to click this drop-down box yet again. And I'm going to do a really wide query here. This is going to take all of our data and group it by event module. And so you see here, we have 3 different data types. We've got Zeek logs, we've got WinLogB, and we've got Suricata. So in order to start doing a little bit of light hunting with our host-based data, let's filter into WinLogB. So that updates my query. I click Hunt. And now I've got a bunch of results down here. So the next thing that I might want to do, because this could be hundreds of records, this could be thousands of records, I don't necessarily want to page through this looking one row at a time for anomalies. Let's use our group bys to make this a little bit more interesting, to collapse some of the unique values down and do a little bit of extra grunt work for us. So currently I'm just grouping by event.module, but what if I wanted to add an additional field to group by? So let's say I want to also group by source.ip. So when that refreshes, you see that I'm grouping by WinLogB, but I'm also grouping by source IP. And so that tells me, based on looking at all these results that I got, I have 2 unique values in the source IP field. I have 39 instances of this IP address, and I have 4 instances of this IPv6 address. So let's focus in on this IPv4 address, the 192.168.204.172. So I'll click the plus sign there and click Hunt. That refreshes the page. But now I've still got quite a number of results. 39 is not a huge amount, but we can actually do better than this. So again, let's add another group by. And let's say we want to group by destination IP. So again, we're grouping by event module and then source IP and then destination IP. And so we can look through this destination IP list and start to look for interesting IP addresses. So what might stick out as an anomaly? Well, one IP address that kind of strikes me right off the bat is 8.8.8.8. Now, most of you are familiar, that's Google's DNS server. And so you might be using that at home. You might be using that in certain networks. But let's say that for our hypothetical enterprise network, let's say that all of our internal Windows endpoints are configured to use an internal DNS server. And so therefore they should not be connecting out to an external DNS server. And they shouldn't be connecting out to Google's DNS server at 8.8.8.8. So let's use that as kind of the starting point for an investigation to try to figure out what's going on here. So let's click the plus sign here. That's going to update my query. I can click hunt, and that's going to filter down to just 4 results. And so really we could use the same exact workflow here of drilling into a log. We get a little bit of information. So this first one, when I drill into it, I get my sysmon log. Here's a network connection detected. And we see that, yeah, sysmon actually says the destination host name is dns.google. So if we didn't already know that quad 8 was Google's DNS, well, the sysmon log is going to tell me that. But I don't get all of the information out of the sysmon log. I get some, but I don't get all of it. So now let's cast a wider net. Let's copy that community ID value and let's search for it. And so now we get 5 results for that particular community ID. The first 2, again, have a UID value, and that tells me that these are Zeek logs. And so let's drill into the first one. That's going to be our Zeek DNS log. And so right off the bat, looking at that Zeek DNS log, in the DNS query name field, I see a long string of random characters .onion. Now, this has nothing to do with security onion. And I might know what that is off the top of my head, or I might not, and I might need to look at some of my other correlated logs to see if there's an additional indication of what that .onion is relating to. But even if that doesn't strike me as odd, the fact that there's this long string of random characters, that strikes me as odd. That seems to be something that seems a little bit suspicious to me. We do also see that the response code was NX domain or no such domain. And so that's something that we see in domain generation algorithms where we're spewing out hundreds or thousands of these random looking domain names, and some of them will wind up returning no such domain. And so that's interesting. So now let's go a little bit further and let's take a look at our second entry here. This is most likely going to be our Zeek con log. So again, abstract information about the connection itself. So that was number 2. Let's look at number 3. This is the WinLogBeat log that started off this particular use case. Another thing that I failed to point out when we looked at this log in the first place, the process that generated this is actually dig. Again, dig is not really included in Windows, but this was Windows subsystem for Linux. And so that's where that actually came from. Let's look at log number 4. So this is a Suricata IDS alert. And so this is telling me that this matched a rule looking for a DNS query for Tor, the onion router, hidden domain.onion. So if I didn't already understand, if I didn't already know that .onion had to do with Tor, well, now I know that because of that community ID correlation. And finally, let's look at log number 5. That's another Suricata alert. And this one's actually more serious than that last alert that we looked at. This is for a network Trojan. Specifically, it's for the cryptowall.onion proxy domain. And so now this really makes us suspicious that there's something malicious going on here that we definitely need to engage our incident response process in. And so again, just 3 pretty quick, pretty simple use cases of using that community ID to tie different data types together, both from a network perspective and a host perspective, going in different directions, and ultimately painting a better picture about what actually happened. All right, so that's my demo. So at this point, I'll kind of turn it over to Richard and see if he has any questions, or if there's any questions from the audience. I'll be glad to answer.
Yeah, thanks a lot, Doug. Does anyone have any questions? You can put it into the Q&A box and we'll take a look. Maybe as we're waiting, Doug, could you talk a little bit about what it would have taken to do this sort of investigation prior to the investments you guys made into the community ID?
Yeah, that's a really good question. So, you know, the first step is collecting the logs themselves. And so, you know, you could do that before without necessarily having the community ID values. But you definitely want to have the logs in a central location. You know, I think back to sort of my early years as an incident responder and some of the incidents I worked where we had the logs, but they weren't necessarily in one central location. So maybe we had network logs in one location, and maybe we had some syslogs stored on some syslog server somewhere that we had to go to some sysadmins and get access to. And you know, even then, the challenge you might have is not just having access to the logs, but do they have the proper timestamps? Are you able to correlate based on the timestamps themselves? Are they in the same time zone? You know, I can think of many cases that I worked back in the day where we were trying to correlate and there was time skew and there were time zone differences. And it was just a nightmare, right? An absolute nightmare of trying to correlate logs together. So really kind of step number 1 is collecting the logs and hopefully in some central location so that you can run one query and get all the logs in one shot rather than having to query multiple data sources. And ultimately step 2, and this is kind of the crux of your question, is community ID and the value of it specifically. You know, if we had that sort of step 1, if we had that central log collection in place, then yes, I could correlate logs based on IP address and port information. But at that point in time, you might run into a couple of problems, right? Because, for example, let's take our really this happened in all 3 of the use cases that we looked at, and that's when you're dealing with IDS alerts specifically. Many IDS rules are written to look for traffic on one side of the flow, meaning that you might have a rule that's written to look for return traffic coming back from a web server. And that means that when that rule fires and you as the analyst look at the IDS alert, the quote unquote source is actually going to be the IP address of the web server, which is kind of backwards from what we normally expect it to be. And so if I were to take, say, that particular IDS alert where my quote unquote source IP address is the web server and my quote unquote destination IP address is the client, the web browser. And so I've got my source IP, source port, destination IP, destination port. I might then try to run a query looking for that network tuple. But if I'm really strict about running that query and I say source IP equals this and destination IP equals this, and I hope to get Zeek logs or sysmon logs or something else, I'm probably not going to get them, because when Zeek sees that connection, it's going to record it the way we expect it to record it, meaning the browser is going to be the source IP, the web server is going to be the destination IP. So if I'm really strict about my source IP and destination IP terms and running that search, I might not actually get the extra data that I'm looking for. And that's the brilliant thing about Community ID, is that it abstracts that and makes that problem go away. And so by simply pivoting on that unique Community ID value, I get all of the connections for that pair of IP addresses and that pair of ports, regardless of whether they were source or destination. And that magically solves that problem of pivoting to and from IDS alerts when they might be kind of backwards to our thinking.
Cool. All right, we do have a question. I think this will be a short one, but I think this person is asking for you to better explain the relationship between the existing Security Onion distro and what's coming next. Because what he's asking is hybrid hunting available in the Security Onion new release?
Very good question. So Hybrid Hunter is simply the code name for the next generation version of Security Onion. And so essentially, we have a current version of Security Onion, which we call Security Onion 16.04 because it's based on Ubuntu 16.04. And for the last couple of years, we've been working on the next generation version of Security Onion, which we have given the code name of Hybrid Hunter. And that is a totally separate platform. It's totally different architecture because it's container-based. Those containers are orchestrated using SaltStack, and that enables us to support not just Ubuntu, but also CentOS as well. And so you can go and download Security Onion Hybrid Hunter today. That's going to be beta 2. It's currently in beta release. And you can run that on CentOS or Ubuntu 8.04. Ubuntu 18.04. If you download our Hybrid Hunter ISO image, that is based on CentOS 7. And so it's two totally separate platforms. And the hunting web interface that I showed in the demo, that's only included in Hybrid Hunter. So you're not going to be able to use that hunting interface in the current Security Onion 16.04. You'll have to download the Security Onion Hybrid Hunter Beta 2. And the other thing that I'll kind of tack on there is that my team is feverishly working on Beta 3, and that's going to be coming out real soon now. So depending on when you actually go to download Hybrid Hunter, you'll either be looking at Beta 2 or Beta 3.
Okay. Another question. I'm not sure. I don't know. I think this may just trigger a discussion of what the different types of nodes are in Security Onion, because the question is, will the new version support multiple nodes installation, which I don't quite understand. So maybe you might just want to use that, Doug, to explain like what are the different components of Security Onion, the forwarding and master and all that kind of stuff.
Sure. So what we demoed today was really what we call a standalone installation. It's a single installation of Security Onion that runs all of the components in one installation. So I was running Hybrid Hunter in a single virtual machine, and everything was self-contained within that one VM. So that's kind of the simplest architecture that's standalone. But once you start to deploy Security Onion to an enterprise environment, you're inevitably going to reach a limit, or you're going to need some additional capabilities in terms of deploying additional sensors out to remote offices, or potentially kind of scaling out your back-end Elastic stack to store more and more logs. And so we have this scalable distributed deployment model where you can build a single central server, which is going to control your entire enterprise grid. And you can then add one or more what we call forward nodes. And those are your sensors. Those are your network sensors that are running Suricata to monitor the network traffic and generate your IDS alerts. They're going to run Zeek to monitor that same network traffic and generate the lovely Zeek logs that we all know and love. And those alerts and logs are going to be forwarded from the forward nodes to the central server, where it's either going to store them itself or it's going to kind of relay them to back-end, what we call storage nodes that are going to store those logs. And that's where Elastic is running. So that's where we have Elasticsearch that's actually ingesting those logs. And so you can have one or more forward nodes, you can have one or more storage nodes. And so now we have kind of this scalable architecture that as your enterprise needs grow, you can continue to snap in additional Security Onion nodes to scale your deployment as necessary. And to get back to the original question, yes, Hybrid Hunter does support that kind of distributed deployment model. So even though what we demoed was Hybrid Hunter in a single standalone VM, you can do a full distributed deployment with a single central server that's managing lots and lots of forward nodes and lots of backend storage nodes as well.
Okay, along the lines of scaling, we have someone asking about scaling an OS query. So I'm not sure if that, I guess that would have something to do with perhaps how many systems you could have associated with OS query, because it's more like you pull systems running OS query. It's not like they're all continuously connected agents. But yeah, can you talk at all about OS query and scaling?
So my disclaimer up front is that I am not an OS query expert. My OS query expert is Josh Brower, and he would be much better to answer this question than I would. But what I would say is that I seem to remember a discussion that we had on our internal Slack channel about scalability of OS query. And I seem to remember a screenshot that Josh posted that was talking about running OS query in an enterprise that had hundreds of thousands or potentially millions of endpoints. I don't know a whole lot of details about that, but I think it is one of those things that they're aware of the need for scalability, and if it's not already scaling to that level, they are working on making it scale to that level. So, from our perspective, if we wouldn't feel comfortable kind of encouraging folks to use OS query unless we were comfortable with the scalability of it. So I'm pretty comfortable that it's going to scale quite nicely for most of the organizations that we deal with.
Okay. And we have a question in the webinar chat about the update or upgrade path. Do you suggest a total new install for Hybrid Hunter, or can you migrate settings from 1604?
So one of the issues that we have on our roadmap for Hybrid Hunter is to support in-place upgrades from the current Security Onion 1604 platform to the new Security Onion Hybrid Hunter. That is going to be a little bit involved because it's kind of a multi-step process. If you think about it, you're running Ubuntu 1604. And if we want to try to get to Hybrid Hunter on the Ubuntu side runs on Ubuntu 1804. So in order to kind of bridge that gap, we're going to have to take Security Onion 1604 and upgrade the base Ubuntu operating system to 1804. And then on top of that, upgrade kind of the installed Security Onion components from the 1604 version of the components to the container-based Hybrid Hunter version of the components. So it's going to be an involved process, but we do plan to have some sort of facility for that. And we haven't started working on that yet, but we know that that's something that we have to get done before we can do a final release of Hybrid Hunter. So it is important to us. We are going to make sure that that gets done.
All right. And a question came in. Is it possible to forward network flows instead of using sensors? So I'm wondering if this gentleman has maybe NetFlow probes, or they're getting NetFlow off of their routers or something like that. And they're wondering if there's some facility to ingest that on Security Onion.
So it's a good question. I believe that there is a way to ingest NetFlow using Logstash. So as we talked about, Logstash is a part of the Elastic Stack. And I believe that there is a plugin for Logstash that will consume NetFlow. I don't have any experience with it personally, but I believe we do have some folks in our community that are running that.
Oh, that's cool. Yeah, that might be a good question for the maybe Reddit or the Google group or something, so that there's a record of it, and anyone who is involved with that could potentially share what they're doing.
Absolutely. Great point.
Yeah, that is if you're not aware of it already, Doug has a great support system in place around Security Onion, whether it's posts through Twitter or the blog, or where the source code is stored at GitHub or on Reddit or on the Google group. You will be able to find a way to get in touch with somebody in the Security Onion project, and they are very responsive as far as answering questions.
We try.
Oh, you guys are, definitely. And I've been known to say a few words here and there. Usually
that's right. I've seen you
in the
chime in
documents
quite a bit, especially on Reddit, and we certainly appreciate that.
Yeah, I do like the Security Onion channel on Reddit. It's populated by some of the more interesting people who have who are trying to solve problems, which I like.
That's right.
Okay, well, let's see. Any other questions? Last call. Put them in the Q&A. Okay, well, Doug, thank you so much for coming back and sharing all this. Oh, someone just put a question in. Let's see what it says. Is there a Slack channel for Security Onion?
Is there a Slack channel for Security Onion? We are not quite as cool as the Zeek folks. We do not have a public Slack channel yet, although we may consider that at some point in time. We've had some internal discussions about that, and it kind of comes down to, as Richard pointed out, we have the mailing list, we have Reddit, we have Twitter. We already have quite a number of kind of active social media channels. And so we're trying to control the number of channels that we have to make sure that we can remain responsive to all of them. And so that's why we haven't really kind of opened up a public Slack channel yet, but it is something that we're considering for the future. So maybe stay tuned, ...
Okay, one more thing. Yeah. Well, if people would want to be answering in the Slack channel, that's a great way to get involved too, right? Post to some of the other Security Onion social media that, hey, I will answer questions. I volunteer to do so in the forthcoming Slack channel, and that may encourage it.
There you go.
All right. All right. Well, thank you so much, Doug. Always wonderful to have you sharing your expertise and knowledge and the work that you guys are doing over there. And thank you to all the attendees as well. I hope you enjoyed this. And if you have any questions, feel free to either contact Doug through one of the mechanisms that he has listed there. You can always, if you want to drop something into the Zeek Slack channel, I'm sure we'll get the answer to you that way. Or, Doug is very responsive and his team is very responsive. So we'll figure out a way to help you.
Awesome. Thanks, Richard. And thanks, everybody. Appreciate it.